Hey everybody, it's Adam again. Tonight we're gonna go through the first few dimensions in the math map and go through the first 18 weeks of the instructions and the various workbooks that you will be going through as you go through the math map. So we're gonna so this is basically dimensions. I call it dimensions part one. So there's a part two, yes. That'll be next week. So we're going to look at 0D through 2D. So 0D, 1D, 2D, all these first three dimensions, which covers the first 18 weeks of the school year. So as we go through the math map, it is separated into 6 different dimensions, starting with 0D, as I said, and then 1D, 2D, 3D, 4D, and then ND. And as you see, I have in the chart the weeks that basically they are grouped in the lessons are grouped into these various dimensions. And today I'm going to discuss about just these first 3 dimensions, which covers weeks 1 through 18, as I said. So let's start with 0D. 0D is, the 0 dimension, the dimension without any kind of height, any kind of length, any kind of width. It's basically just a dot. That's what 1D or 1D 0D is. It's just basically a dot in space. Um, Even this dot is too big on my PowerPoint slide here. The 0 dimension, if you zoomed in on that dot, you get some dimension there. You get a little bit of a radius of the little circle, but in 0D there's no radius. There's nothing except that one specific point in space. So but graphically and how we can show it is basically a dot. And then if we move on to the first dimension, and I'm going to go through all the dimensions as a visual of how we look at dimensions. So if we go to first dimension, what we're going to do is we're going to take that dot that we have there and we're going to stretch it um, in one direction. Well, pretty much 2 directions, actually one way and the other. But so we're just going to stretch it out, kind of like taking silly putty, a thing of silly putty or Play-Doh, and you just stretch it out in a straight line, and you're going to create a line of one dimension. So it only has one dimension, and so it's pulled like the real number line that we discussed in the domains lecture yesterday. So this one dimension. And then if we go into the second dimension, we're going to take that line and we're going to stretch it the other way. And it's going to create like a gigantic paper, which has 2 dimensions, both the length and the width, these 2 different dimensions. And then when we go to the third dimension, we're going to pull that now the third way, which kind of creates a giant, imagine a box, but really it's all of space. Pretty much how we live in the world. We live in a 3-dimensional world, and so it's how we interact. And this is kind of like this is where we live in this kind of dimension. We have 3 different directions. However, when we add a 4th dimension, we kind of this gets a little bit more hard to conceptualize. I mean, the easiest on a piece of paper or on a computer screen is to show the second dimension because it's flat. Third dimension, you kind of can do it even though it's still kind of a flat position, but you can pull it back as you see as a cube. But the 4th dimension is a little bit trickier, and often it's showed as in the math map. It's showed as kind of like what they call a what's that thing in the Marvel movies? The that the starts with a T, but I'm looking at it in a different way. It's kind of like you take the 3rd dimension and you're going to kind of move it through time. It, it could be the a box within a box in a sense, but if we go through time, we have like a 4th dimension. And often the 4th dimension is like they it's our time. It's like we're in the third dimension, and yet the third dimension is moving through time. And so there's this other third dimension, and it's at the same place, but it's at a different time. So it's like it adds this fourth dimension of, in a sense, time, or kind of this 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 box within a box. It's a little more difficult to 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 visualize and put on paper. Um, and then when we get into farther and farther dimensions, it's called the n dimension. Here, it's just a very general term, and it's kind of got to use your imagination. Kind of, it's almost outside of what we can really understand. So, but this is like that ND. But we can look at patterns, and that's the beauty of understanding some of the easier dimensions like 2D, 1D, 2D, 3D, so we can see the patterns repeat itself, and you just do the maths in this like very same way, just in by using more variables or more these dimensions. So the patterns and dimensions, if we look at, we basically have no axis in the 0D, but then we go one axis, two axis, three, four, and n axis at the end. So it just adds an axis. An axis basically is, when we add another one, it's always, in a sense, perpendicular to the previous one. So with zero, there's no axis. So you add this one line, and then you go perpendicular to it, and you get a second one. You go perpendicular to those, since you're coming in on this other angle, it's a third. There's a, again, now fourth dimension is a little bit trickier to understand. Where's that perpendicular to that third axis? But if we use imagination, we can kind of there's this idea of that, and you can do the maths as you go into the higher and higher dimensions. And there are various terminologies that we use when we look at these different dimensions. So let's start with the zero dimension. Let's get to the point, as the pun is very much intended. Let's get to the point. So this is basically what they call singular space. It is as I said earlier, it is just a dot in space. It's just, there's no length, there's no width, there's no height, there's no depth, there's nothing. It's just this dot. And weeks 1 and 2 will cover this. This singular space. It's basically we're going to look at the numbers that we represent in math. We use numbers to represent amounts of things. So we're just going to look at the numbers themselves, the specific numbers. No arithmetic, just what is the numbers? I mean, there's some arithmetic when you get to place value, but really it's just the concept of the numbers and how we construct them. So again, no dimension in any direction, no any dimensions, just a single point, and there are just these individual points that we're going to talk about. And these 2 weeks, we just look at individual numbers, and we look at the beauty and benefits of the number 0, and we're also how we construct numbers via digits and place value. That's pretty much what the first 2 weeks are going to get you. So when you study in week 1, you're going to look at this booklet. Is a special booklet. I call it a special booklet just because it is an introductory booklet. When you look at the this booklet, you're going to look at we're going to see a lot of information, and really what this booklet is trying to do is it's trying to help you to understand how to use the math map. There's a lot of information there. There's you can get also help. I have other videos where to show how to use math map. This one will go through it. It'll show you each section. You should do this here. You should do this here. You could use this here. Gives you suggestions. But and it will also show you what they call the seeing the unseen, give you examples of that on the bottom of each page in order to get your child interested in thinking about looking at math in the real world and just finding patterns and symmetry and so forth, and mathematical constructs in nature and where the so it's a way to um, basically introduce. So that's what this booklet is. It's also going to introduce how to so sorry. It's good to read thoroughly this book, just as a point. Just read it thoroughly. Could be a lot of stuff there, but as a parent and you want to help your kid, you can go through this and just read it and try to grasp the idea of the math map and how to use it. And as I said, it gives ideas for the week 29 booklet, Seeing the Unseen, but it also will introduce zero and even also the number one actually as well, because these are very important, concepts. There's the zero is like the origin. So whenever you get when you start graphing and you find that specific point where the two, say the x and y axes meet, that's the origin, that's zero. That's where everything starts from, that point zero. It is also a hidden number at times, but it can be very powerful. It can take a very complicated equation, and if you have zeros, you could find roots, and you can find um, various kinds of numbers, and it could clear out certain parts of the equations. And it's also hidden in numbers themselves, and they're like so if you look at this example here, so you have a real number 4, it equals the complex number 4 plus 0i. So that 0 basically makes the imaginary part of the complex number go away and you're left with just the real number 4. So these are equal to each other. The real number 4 is equal to the complex number 4 plus 0i. So with that 0, it makes that part of the complex number, kind of the imaginary part, go away. So it also holds place value in numbers. It makes the difference between 19 and the number 109 and the number 1900. These are very different numbers. They are not the same because the zeros take the place of certain parts of the number, and it's getting rid of, say, the tens place or the ones place. So these hidden, but it can be used very powerfully in math. Also, there's identity laws that use 0 and also 1 to make it so we know that anything plus 0 will equal that itself, and it's anything times 1 will equal itself. So we know these laws are very important. We also understand that we multiply by 0, we get 0. Anything by 0 is 0, and we cannot divide by 0, so that's undefined, and sometimes it's called imagination. um so 0 is very powerful and very useful in math. Also exponents, if you have something to the 0 power, it all will always equal 1. So these are examples of using 0, and you'll kind of go through that and understand the number 0. In week 2, we're going to get into, we're going to use place value. We're going to learn how numbers are constructed using place value. The focus that we should focus on when you learn this with your child, with your student, is to focus on the decimal number construction, which is also considered base 10. So this is the normal numbers that we use. There's also other bases, and you can learn those as well, but keep the focus on base 10 until you're very used to it, and then you can start to kind of stretch beyond that that base 10 and get into some of these other bases. They'll show you base 2, base 3, even base 4, base n. Base 16 is considered hexadecimal, so those are hexadecimal numbers. These are other different kinds of bases. Base 2 is often used in computers, right? Zeros and ones. So this is the basis for uh, computers and how they work is using a base 2. So to understand that can be very helpful if that child is leaning towards maybe some kind of future in computers or so forth. So to understand base 2 and also base 16 can be very helpful. But it's also, I think, going from being able to go between the different bases gives you a more firmer grasp of how numbers are constructed. So we can, because when we look at base 10, we kind of basically understand it. We understand if it's 1, it's 1 1. And if it's 10, it's 110 and 0 ones. We can kind of get that by just understanding, oh, 10 is that's number. But when we try to switch between bases, it can be a little bit confusing. But if we start to master these other bases, we really solidify our understanding of our normal base 10. So these are so I call them stretching beyond is to get into these other bases. But the focus should be on the decimal numbers, helping the child understand these the base 10. So you also learn relationships and sets in this week using Euler and Venn diagrams along with set notation and terms. So as a note, that name Euler is pronounced Euler. Sometimes it's confused as Euler or something else. But if you want to sound smart, you can say it's just Euler. It's, I think, a Swedish German mathematician. So you'll use Venn diagrams, Euler diagrams in order to understand sets and relationship between numbers, just like I talked about in my domains video. So that's pretty much what you're going to do for the first 2 weeks. It's just looking at numbers, mainly focused on doing that. And then we'll move on into the first dimension, which will cover, I think it's weeks 3 through 8. These are the weeks when we're in what they call linear space, in that line, going through, in a sense, the things on the line in the one dimension. It means one variable. It means that it's this dimension stretching from negative infinity to infinity, but it's a single line. And since there is dimension, we actually can move about now. In the 0, we couldn't. We were just kind of like just looking at the numbers. Now we can move about using arithmetic in order to go from 2 plus some number equals another number on the same line. So we're now going to go through arithmetic in these weeks. These 6 weeks, we go through arithmetic, starting using addition, subtraction, multiplication, division, exponents, and equations. So we're going to go through these operations and begin to be able to work through equations and do comparisons and calculations. So week 3, that is basically the addition and subtraction week. So you're going to learn and focus on comparing, equal, not equal, greater than, less than, greater than or equal to, less than or equal to, these kind of comparison operations in order to be able to compare one side of your equation from the other. But again, we're looking at plus and minus. So we want to focus on, we're going to be not only just comparing, but we're going to do addition and subtraction. So you see, we can compare these all sorts of different kinds of ideas, numbers, and unit of measures, and temperatures, and difference between negative and positive. And we're comparing all these types of groups and sets of numbers. And then, so in the linear space, we look at it again. I don't want to get too much in the details of adding and subtraction because I think most people understand how to add and subtract, multiply and divide. So that's what you're going to do. Weeks 4 through 7 we're going to get to exponentiation. And I just put here at the bottom of these few little things that can kind of be confusing. And when you use, why do we have logarithms and roots, and why not just one or the other? Because usually we have addition, and then we have the opposite or the inverse, which is subtraction, multiplication, and the inverse is division. In exponentiation, the inverse can be roots, and we can also use logarithms, and it mainly depends on what you're going to be looking for in solving. I think, especially when you get into some kind of more algebraic things like trying to solve for x, it depends on what x is. So say you have this equation, x squared equals 9. So you're looking for what they call the base. X is considered the base. If you look at in the exponents, so the structure of the exponents is P equals Bn. The power equals base times the indice. So in this case, we're looking for the base. So we're going to use a root. We're going to do whatever the indice is. So if it's 2, in this case, it's 2. We're going to take a square root, and we're going to be able to find and solve for what x is. In this case, it could be plus or minus 3. But say we're looking instead at an equation like 3 to the x equals 9, where you're looking for the exponent part, the indice. That's when you need to use a logarithm to solve for equations like that. And that'll get explained more in detail as you go through the course. So that's I just put that there just to maybe give an idea of why we have these roots and logarithms, not just one thing. So we need to use it for, depending on what you're looking for, you're going to use a specific operation. Okay. So in week 8, we get into equations, and so you'll find these two things. One is called, I don't know if it has a special pronunciation, GIMA or not. This GIMA just is an acronym for the order of simplifying an expression. So this is important to understand. There's an expression and there's an equation. They're kind of two different things. Expressions are just simply made up of numbers, variables, and operations, but they're not equations. An equation will have an equal sign. You're equating two sides, and they'll have equal or maybe a greater than or less than type of what do you call it, operation there. But the expression is just the one side. So you have 9 plus 8. That would be kind of like an expression. 9 plus 8 equals 17 is your equation. You have an expression, 9 plus 8, you have an expression, 17, and you equal them, and it becomes an equation. So the GIMA is basically, because at first I was like, what is GIMA? And I realized it's really just synonymous with PEMDAS, which you're probably more familiar with. So G is for groups, that's the parentheses. I is for indices, that's the exponents. M is for multiplying or dividing, because they're inverse and they're very similar. So MD, and then A is for addition, subtraction, which is the AS. So it's really just the same concept, just a different name. So don't get confused like you have to learn something completely new. This is just, how do you simplify, take an expression and make it the most simple that it can be. And then there's the opposite, which is AMIG. So this is the order of solving an equation. So when you have an actual equation with the equal sign, you're going to do your addition and subtraction first, depending on what's on what side. And you're going to do your multiplication and division. Then you're going to deal with your indices, and you're going to then deal with your groups and work through those as well. So you're basically going to do the opposite of the GIMA. You do the AMIG. So this will help you to be able to find X. That's the kind of the normal thing which you do in algebra, find X. And so that's what you're going to use that to solve an equation, to find the solutions to the equation. Okay. And then actually the I3 page gives you more operations than what you had already learned. It gives you sine, cosine, absolute value. It gives you a whole bunch of them. You can take a look at that, but focus on learning the ones that you know, and you will get into the sine, cosine, and some other ones later in the lessons in later weeks. So just kind of get used to them, but later you'll focus on them. Be focused on what you're learning in each of the weeks. Okay, and finally, we're going to look at the second dimension, plain facts. Plain facts, because remember, the second dimension is like a plane. It's in planar space. So this is weeks 9 through 18. This will take you into the second semester. So after the winter break, usually you get into, so before the winter breaks, challenge students are finished at week 15. So after is you get 16, 17, and 18, that'll finish up 2D. So this again is 2 dimensions going both directions infinitely, and creates a big gigantic plane, or it's kind of like a giant big piece of paper that now you're in. You can move about even more. You can and you can get into functions and other things like that. So you can look, you're gonna, during these weeks, you're going to look into various kinds of lines. You're going to look at various kinds of 2D shapes, like circles and triangles and squares and so forth like that. You're going to learn how to use actually various math equipment, like a compass and a ruler, and measure shapes and so forth. You're going to get the beginnings of trig functions and concepts as well in one of the weeks during this time. And then you're going to also do intersections of various shapes and so forth, and do transformations. So that's what you're basically going to do in the 2D planar space. So week 9 is basically dealing with straight lines. So you're going to learn the terminology of and how to graph lines. So you're going to learn things like slope, y-intercept, coordinates, midpoint, distance, anything that really is devoted to a line. You're also going to learn the forms of linear equations. There's 3 of them. There's the point slope form, there's the slope intercept form, and also the standard form. And if you do a little manipulation, you can go between the 3 forms pretty simply. So these are the various kinds. You normally see it, a lot of times I see it in point intercept form, like y equals mx plus b. But sometimes it depends. You might just get a slope and a point, and you have to figure out a line based on that slope and point. So then you get the point slope intercept, point slope form. So it just depends on what you're given, but you learn the 3 types. So then we move on to week 10, and now you're getting into intersected lines. So not just one line, but you can have a second line that intersects it, or sometimes it can actually be parallel. So you're going to learn how to graph inequalities. So you're going to say you'll get a couple inequalities, and you're going to define what region you have to shade in based on the inequality. You're going to learn angles between those intersections. So if you have 2 lines intersecting, they'll create angles, and you have to be introduced to angles. And you'll also, as I said, parallel lines. So intersecting lines versus parallel lines. So intersecting, they intersect, as they're said, and then parallel is they never intersect. And you'll learn some of the various things about these. So like an intersecting line, if it's a perpendicular intersecting line, that just means you'll know based on the slope of the 2 lines. If one is the negative reciprocal of the other one, then you know it's perpendicular. If they both have the exact same slope, they're parallel, unless they're exact same line. So you'll learn those types of concepts when it comes to intersecting lines. And then as we go into week 11, we get into curved lines, and we get into some of the higher order types of equations. So linear is where the variable x is to the 1 power, basically. It only is x to the 1. Or in general, we don't even write the 1, we leave it as x. But when we get into curved lines, we're getting to x squared, x cubed, x4, all sorts of higher order equations. So higher order functions, power functions. Power functions talking about a function that has to do with it having a square or a cube, or that's what it means by the power functions. And then we get into other curved functions like logarithmic and trigonometric functions. These are also very curved types of lines. We also learn about we get some function notation. So we can start to learn what a function is and how the notation like f of x. We learn about asymptotes. We get some asymptotes. Asymptotes are basically lines that a graph will go towards and kind of get closer and closer to, but will never reach. So there's some functions that have an asymptote, like let's say 1 over x, because it cannot get to 0 because you can't divide by 0. So x could never be 0, but the function gets close to 0, but it doesn't touch it. And so there's an asymptote. And it's a vertical line on the graph. We learn about local max and min, where kind of bumps and valleys and hills in the curves. And we learn a little bit about that. And we learn slopes of slopes. So we learn slopes with linear equations. We learn slopes with curved, but also the slope of the slope. Is it increasingly increasing, or is it increasingly decreasing? Has to do with concavity, the way it curves, this way or this way. So these are important concepts when it comes to curved lines. And they also introduce, they kind of introduces limits earlier. You will see the concept of limits, but this one gives a whole section on limits on the I2 page. So you kind of get to the concept of limits, where you get close and closer to a certain point, and what does the output tend to go to. So the concept of limits, and that's to understand the concept of limits helps us to understand some higher level maths like calculus, because it's important to find that's part of the learning about derivatives. So the limit theorem is important to grasp. Okay, so then you're going to go through weeks 12 through 14. I put them all together kind of here because it's really about lots of shapes. So you kind of get, I call it kind of fun. I guess it depends on the student. I think this kind of gets a little bit away from so much calculations, and you're just kind of look at terminology of various shapes. So it could be a little bit lighter on as they go into the end of the first semester, and you got to learn about different kinds of polygons, triangles, quadrilaterals, regular polygons. You learn about circles and ellipses for a week, and all the terminology around circles and ellipses. And you get to the week 14 where you do constructions, and that's where you get your ruler out and you get your compass and you get to construct various shapes, and you get to do bisecting of angles and of the sides. And so it can be kind of a fun activity in these. I'm not guaranteeing that here. Each child's different, but I think this kind of can be a little bit more fun than the rigorous calculating and learning all that equations and all that stuff in the earlier weeks. So then we get into week 15. So this week 15 is the assessment. This is the end of the first semester. And it's just a review and see where the child is at through the first semester. It's a good time to spend reviewing all the weeks up until week 15. And then you go into winter break, and then we come back nice and refreshed, and we get to week 16. still in 2D, planar space, and we get to begin looking at triangles and circles. We get into, it's kind of like a hit you in the come right back into some. This is really the crux of trigonometry in this in the math map. If you want to look at trigonometry, this is the week to look at it. Week 16, you will be uh, looking at the unit circle, and I would say as my encouragement is to master the unit circle. It's on the I3 page. Master the unit circle, especially the first quadrant, because you can just apply the same principles to the second, third, and fourth quadrants. Just where the negatives are, they'll change. But other than that, if you just really master this unit circle, it'll help you with your trigonometry. So you'll see the unit circle actually earlier, I think, in circles. And on the previous week, when you look at, I think that's week 13, if I recall correctly. That, but you don't have to really worry about it too much. But once you get here, you really try to get this. This is something I would really encourage to master, because that'll help you a lot with the trigonometry. So, and also learn this, SOHCAHTOA. Maybe make it a chant. Maybe you write it down. This will help you with your sines, cosines, and tangent. So basically, SOHCAHTOA means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. If you get that down, that's another thing you can use in order to understand how to remember what sides you need to use. And you put sine of 30 degrees and you're like, what sides are they? Oh yeah, that's the opposite of my angle and then the hypotenuse. So that'll come in handy. It's my gift to you. Okay, so you'll learn how to graph trig functions. They'll be, as I said earlier, they're waveforms, they're curved lines. You'll learn how they're graphed. And then you'll get into week 17. That is intersected shapes. So again, we're still in planar space. So we're still two-dimensional shapes. We're not looking at solid cubes and any of that. We're just looking at, the square intersected with a triangle or a circle with a square in it or something like that, that these shapes are intersecting. And so you're finding points or areas of intersection and how to do that, and using even equations and how to figure out what points are the intersecting points based on the equations. You'll be solving two equations with two unknowns. Earlier, we talked about one equation with the AMIG. You're just going to solve for x. Now we're going to begin to solve two equations with two unknowns. So it'll show you how to do that. Substitution method, or subtracting the two equations from each other. There's various techniques. So you'll learn how to do that because you're in 2D, so you have two unknowns instead, two equations, two unknowns. They're called systems of equations, and you'll learn the techniques there. And then finally, we'll get into week 18, which is going to be about transformations. And transformations, there are various kinds of transformations, and the four that you really learn here are translation, which is basically taking your figure or your function and shifting it without doing anything else, just shifting it to another part, either up, down, or over, on an angle, whatever it is. That's really translation. Then you have reflection, which is what you're going to do is there's a line of reflection and you're going to reflect it like a mirror onto the other side. And then you're going to get rotation, which is kind of a twisting, taking the shape and twisting it based on some angle, maybe a 90-degree angle, 180 degrees, counterclockwise or even clockwise, to be in a different spot. And then finally, dilation was just really the growing and the shrinking of the shape or the function. So these are the different types of transformations that we can apply to shapes and functions. And we learn that here. And then you also learn, as I said, lines of symmetry. So, and not only in reflection, but just looking at, say, like a square, how many lines of symmetry are there? There's one going straight down, one going across horizontally, and even the two on the angles. That just basically, if you split in half in those directions, the other half is exactly the same. So you can fold it right there and it'll perfectly line up with the other side. So these are lines of symmetry. And so this is basically the first 18 weeks, the first 3 dimensions that you're going to be dealing with. And the next week, I'm going to go through the last 19 through 30, whatever how many of those weeks are, and we'll discuss on what you're going to do in those lessons. So thank you for joining, and I would hope to see you next week. Thank you.